Hi, I'm Kaylee, a member of FLL Team 9462, the Blockinati's, and today I'm going to show you how to make your robot follow a line like it's on a racetrack. Select Project Properties from the top right page drop-down. At the bottom left, click Add. In Variable Name, type Last Error and select Type Numeric. Click Add again and type Derivative in the variable name and select Type Numeric. Click Add again and type Integral in the variable name and select Type Numeric. Click Add again and type KP in the variable name and select Type Numeric. Click Add again and type KI in the variable name and select Type Numeric. Click Add again and type KD in the variable name and select Type Numeric. Click Add again and type Degrees in the variable name and select Type Numeric. Click Add again and type Black Threshold in the variable name and select Type Numeric. Click Add again and type White Threshold in the variable name and select Type Numeric. Click Add again and type Range in the variable name and select Type Numeric. Click Add again and type Time in the variable name and select Type Numeric. Click Add again and type Power in the variable name and select Type Numeric. Click Add again and type Exit in the variable name and select Type Logic. Click Add again and type Brakes in the variable name and select Type Logic. Now let's start the programming. First we have to initialize all those variables. From the red tab, select Variable Briefcase Set to Write Numeric and pick Variable Last Error. From the red tab, select the Variable Briefcase Set to Write Numeric and pick Variable Derivative. Hold down the Control key and left-click on a briefcase and drag right to copy. Pick Variable Integral. Hold down the Control key and left-click on a briefcase and drag right to copy. Pick Variable KP. Hold down the Control key and left-click on a briefcase and drag right to copy. Pick Variable KI. Hold down the Control key and left-click on a briefcase and drag right to copy. Pick Variable KD. Hold down the Control key and left-click on a briefcase and drag right to copy. Connect block to the first line of blocks. Pick Variable Degrees. Hold down the Control key and left-click on a briefcase and drag right to copy. Pick Variable Block Threshold. Hold down the Control key and left-click on a briefcase and drag right to copy. Pick Variable White Threshold. Hold down the Control key and left-click on a briefcase and drag right to copy. Pick Variable Range. Hold down the Control key and left-click on a briefcase and drag right to copy. Pick Variable Time. Hold down the Control key and left-click on the briefcase and drag right to copy. Connect block to second line, pick Variable Power. Hold down the Control key and left-click on a briefcase and drag right to copy. Select Read Logic, pick Variable Exit. Hold down the Control key and left-click on a briefcase and drag right to copy. Select Read Logic, pick Variable Brakes. From the yellow tab, select the motor icon. Select Reset and Motor B. From the yellow tab, select the motor icon. Select Reset and Motor C. Shrink the screen so you have room for a large loop block. From the orange tab, select the loop icon and draw a large loop on the screen. Connect the code to the loop. Now onto the line follower. From the yellow tab, select the light sensor. Select Port 2 and read light intensity. From the red tab, select a math block. Also, select a briefcase and set to write numeric. Select Add Variable in the briefcase block and add numeric variable error. Connect the output of the light sensor and connect to the first input on the math block. Select Subtract Operation and set B to 50. 50 is the edge of a black line if you have calibrated your light sensor so that black is 0 and white is 100. Connect the output of the math block and write to error. This is how far you are from the edge of the line. Error is used for the P part of PID. Hold down the Control key and left-click on the error briefcase and drag right to copy. Start a new line of code and connect to the first line. Select Read Numeric. Hold down the Control key and left-click on the error briefcase and drag right to copy. Select Variable Integral. From the red tab, select a math block and choose Advanced. Connect Error to A, connect Integral to B. In the formula box, type A plus open parentheses B times C close parentheses. Hold down the Control key and left-click on the error briefcase and drag right to copy. Place at the end of the second line and set to write numeric and select Variable Integral. Connect the output of the math block to the integral write block. Let's add some comments to our code. The first line is calculate error. The second line of code calculates the cumulative error and stores into variable integral. This is the I part of PID. This line of code will calculate the predicted error, which is the derivative part of PID. Hold down the Control key and left-click on the error briefcase and drag right to copy. Start a new line of code and connect to the first line. Hold down the Control key and left-click on the error briefcase and drag right to copy. Select Variable Last Error. From the red tab, select a math block. Select the subtract operation. Connect error to A input of the math block. Connect the last error to the B input on the math block. Hold down the Control key and left-click on a right error briefcase and drag right to copy. Select Variable Derivative. Connect the output of the math block to the right derivative briefcase. Hold down the Control key and left-click on the Read Error briefcase and drag right to copy. Hold down the Control key and left-click on a right briefcase and drag right to copy. Select Variable Last Error. Connect the read to the write block to store the current error in the last error. This line is the guts of the PID controller. It calculates power corrections for each wheel. Hold down the Control key and left-click on the Read Error briefcase and drag to start a new line. Select Variable KP and connect the block. Hold down the Control key and left-click on the Read Error briefcase and drag to copy. From the red tab, select a math block and choose the multiplication operation. Connect error to A and KP to B. Now copy these three blocks and select Read KI and Read Integral. Connect these two variables to the math multiplication block. Copy these three blocks and select Read KD and Read Derivative. Connect these two variables to the math multiplication block. Drag a math block from the red tab and select Advanced. In the formula box, type open parentheses A plus B plus C close parentheses times D. Type 1 in D. If your robot corrects in the wrong direction, change this to -1. Connect the output of the proportional math block to A. Connect the output of the integral math block to B. Connect the output of the derivative math block to C. Hold down the Control key and left-click on the right briefcase and drag right to copy. Select Add Variable and type Correction. Hold down the Control key and left-click on the Read Last Error briefcase and drag to start a new line. Connect the block with a parallel thread from the top of the loop. This next line code will steer the robot using unregulated motors. This is the key to having a fast PID controller. Using tank drive or steering is much slower because all of the processing done inside the tank or steering blocks. The only thing unregulated does is set the power of the motor. Copy another read block. Set the first block to read power, the second to read correction. Drag a math block from the red tab, select the subtract operation. Connect power to A and correction to B. From the blue tab, drag an unregulated motor block and set to B motor. Connect the output of the math block to the motor block. Drag a math block from the red tab, select the addition operation. Connect power to A and correction to B. From the blue tab, drag an unregulated motor block and set to C motor. Connect the output of the math block to the motor block. Now you have a line follower that will run till the loop finishes. Next, we will add 5 ways to exit the loop, making this a very versatile myblock that you can use several different ways. Now we add the exit logic. First, insert a wait block. This delay ensures the correction is updated before steering the robot, and create a new loop branch. Set wait to 0.01. Then add a read numeric and select degrees. Drag a comparison block from the red tab and select greater than. Set the read block to degrees. Connect degrees to A on the compare block and leave B as 0. Now we insert the first of 4 nested switch blocks. Switch to tabbed view and stretch across the PID loop. The check tab of the switch is used if you are checking degrees rotation as your exit condition. Drag a motor read block from the yellow tab and set to B motor. Control left click to copy the motor block and set to C motor. Drag a math block from the red tab. Select Advanced and connect B motor read to A and C, motor read to B. Control left click to copy read degrees. Drag a compare block from the red tab and select greater than or equal to. Connect the output of the advanced math block to A and read degrees to B. We need to edit the formula box of the advanced math block to find the average rotations of B and C motors. Type open parentheses A plus B, close parentheses, divided by 2. Drag a briefcase from the red tab and set to write logic and choose exit. Then connect the output of the compare block to the write block. Next, set the switch type to logic and connect the output of the logic block to the switch as shown. Now we will create the X or false side of the first switch. This side will contain another switch, checking the black threshold to see if it is being used. Drag a read variable block from the red tab and choose black threshold. Drag a compare block and connect the read to A on the compare. Control left click and drag copy the first switch into itself. Connect the output of the logic block to the new switch. Select the check tab of the new switch and delete the first 4 blocks that were copied. Replace them with a read light intensity from the yellow tab and select port 1. Copy a read block and set to black threshold. Connect the output to the sensor block to the A input of the compare block. Set the compare to less than or equal to. Select the X or false tab of the second switch. Change the read variable to white threshold. Then drag copy the switch inside itself. Connect the output of the compare block to the switch logic input. Select the check or true tab of the third switch. Change the variable from black threshold to white threshold. Change the compare block to greater than or equal to. Select the X or false tab of the third switch. Change the variable to range. Drag copy the third switch inside of itself. Connect the compare block to the logic input of the switch. Select the check tab of the fourth switch. Delete the first block. Drag an ultrasonic read block from the yellow tab. Select port 3. Connect the range output to A on the compare block. Change the compare to less than or equal to. Change the variable to range and change range output to inches. Select the X or false tab of the fourth block. Delete the 2 blocks and leave empty. The next to last step is to check to see if the time limit is exceeded or any exit conditions are true. Scroll to the top of the big loop. Insert a briefcase and connect the block. Insert a timer from the yellow tab and select timer 1. Insert a compare block and set to greater than or equal to. Change the write time to read time and connect to the B input of the compare block. Drag copy the read block and set to read logic and variable exit. Drag a logic operation block from the red tab. Select A or B for the logic type. Connect read exit to A of the logic block. Connect the output of the compare block to B of the logic block. Change the outer loop from infinite to logic. Connect the output of the logic operation to the loop exit. The last step is to decide whether or not to apply brakes after completing the move. Drag, copy a write block, drag a tank drive block from the green tab and set to X. Select read logic and select variable brakes. Connect the brake logic to the logic input of the tank drive. This last part of the code checks exit logic for timeout condition to exit loop. These 2 blocks are used to turn on brakes if desired. Now we will make a myblock from the programming. Select everything but the play button and from the Tools drop-down select myblock builder. Name your myblock something like PID underscore line underscore follower. Add 10 variables. Select the parameter setup tab in the first variable. Type power in the name box. Select vertical slider. Set min to 10 and max to 90 and default to 40. Select the parameter icon tab and scroll down and select the speedometer icon. Select variable 2. Select an icon for KP. We like bars for KP, KI, and KD. Select the parameter setup tab. Type KP in the name box. Select vertical slider. Set default to 2, minimum to 0, and maximum to 50. Select the third variable. Type KI in the name box. Select vertical slider. Set default to 0, minimum to 0, and maximum to 5. Select the parameter icon tab and scroll down and select the 1 bar icon. Click on the fourth variable and select the max bar icon. Select the parameter setup tab. Type KD in the name box. Select vertical slider. Set default to 4, minimum to 0, and maximum to 100. Select the fifth variable. Type brakes in the name box. Select data type logic. Select true for default. Select the parameter icon tab and scroll down and select the red block icon. Click on the sixth variable and select the degrees icon. Select the parameter setup tab. Type degrees in the name box. Select horizontal slider. Set default to 0, minimum to 0, and maximum to 9,999. Select the seventh variable. Type black threshold in the name box. Select vertical slider. Set default to 0, minimum to 0, and maximum to 40. Select the parameter icon tab and scroll down. Select the black block icon. Click on the eighth variable and select the white block icon. Select the parameter setup tab. Type white threshold in the name box. Select vertical slider. Set default to 0, minimum to 0, and maximum to 100. Select the ninth variable. Type range in the name box. Select vertical slider. Set default to 0, minimum to 0, and maximum to 80. Select the parameter icon tab and scroll down. Select the ping icon. Click on the 10th variable and select the watch icon. Select the parameter setup tab. Type time in the name box. Select vertical slider. Set minimum to 0, maximum to 180, and default to 5. Select finish. Now we connect the myblock inputs to the program. Connect power to the power right block. Connect KP to the KP right block. Connect KI to the KI right block. Connect KD to the KD right block. Connect brakes to the brakes right block. Connect degrees to the degrees right block. Connect black threshold to the black threshold right block. Connect white threshold to the white threshold right block. Connect range to the range right block. Connect time to the time right block. Here is what your myblock will look like in a mission program. Time is always an exit condition because if your robot gets stuck, it will move on to the next myblock and maybe salvage a mission. The other 4 exit conditions are activated by putting a number other than 0 into the variable input box. If you want the robot to follow the line for 1000 degrees of rotation, put 1000 in the degrees box. Or if you want the robot to stop when it sees white on the second light sensor, type 90 in the white threshold box. Tuning your PID values, power, KP, KI, and KD will be another video, but some quick pointers. Leave KI 0. Start with 30 power. Higher KP makes the robot track aggressively. Too high and the robot will oscillate out of control. KD damps out the KP oscillations. This can be done via trial and error, but the follow-on video will show process that is repeatable. If you like this video, please give it a thumbs up and subscribe to our channel.